So class, now we want to estimate the area under the curve, which is area between function. So integration can also be used to find the area between two graphs here by subtracting integrals. What does it mean here? If you have two functions, the first one, for example, this curve is given by fx, and this curve, which is quadratic function, is given by gx. So now if you see this one, you can see fx at this region E to B, this fx is greater than gx. Why I said like that? Because this graph is above, this fx graph is above gx graph. So how can we compute area? Area enclosed by fx and gx between intersection points A and B as given by this figure equal to, we need to integrate from A to B, fx, which is the graph that is above of the other, and minus A to B gx, which is the graph below of the other graph. That is, when we simplify this one, we got the integration starting from A to B, fx minus gx dx, where here your function fx must be greater than gx in the region of AB. So class, now we go to this example 3. We need to find the area of the shaded region by the curve y equal to x squared plus 2 and the lines y equal to negative x, also x equal to 0 and x equal to 1. So now, the first step here, we need to check between these two functions, which one is the greater function. So now for y, we have y equal to x plus 2, and then we have y equal to negative x. Let's say we set here x equal to 0, so we can see based on this limit, we set first x equal to 0, for this one y equal to 2, here y equal to 0. And then when we set x equal to 1, we can see here for this one y equal to 3, this one x to the power of 2, and for this one y equal to negative 1. If you can see here, the value given by this function is greater than the value given by this function. So we can conclude here x squared plus 2 is greater than negative x. The other way is to plot a graph, but maybe this one takes time. So actually, the graph for this one is given by this shape, cross at x equal to 2 here. Cross at y equal to 2 here. And the line for y equal to negative x is given by this line. So here we have for this one x equal to 0, and when, for example, this one x equal to 1, means that the region that bounded by this curve, this line, this x equal to 0 and also x equal to 1 is given by this region. And we can see this y equal to x squared plus 2 is above function, okay, above than this function y equal to negative x. Means that step number 2, we need to use a formula, integration AB fx minus gx dx. Fx is the above function, gx is the lower function. So now we have equal to integration, our limits start from 0 to 1. Fx is x squared plus 2 minus negative x dx. When we solve this one, we have x squared plus 2, integration of x squared plus 2 plus x dx, which is equal to x to the power of 3 divided by 3 plus 2x plus x to the power of 2 divided by 2, which is our limit start from 0 to 1. That is, when we solve this one, we've got the answer 17 over 6. So class, what I did here actually, I determine the upper and lower function, which is the upper function is given by y equal to x squared plus 2, and the lower function is given by y equal to negative x. And then I compute the area based on the formula. Instead, the answer here is 17/6. And this is the graph of that 2 function. So now we go to the example 4. The question asks us to find the area of the region that is enclosed between the curve y equal to x squared and also y equal to x plus 6. If you see in this question, we don't have any value of x. So class, for this question, we need to find the value that intersect between these two functions. If let's say I plot this function, I have the first one y equal to x squared and then y equal to x plus 6. When I set here for this one, x equal to 0, we have y equal to 0. This one, when x equal to 0, we have y equal to 6. And then let's say here for this one, we set y equal to 0, we have x equal to negative 6. We can plot here for the first function, it is quadratic function that touch this 0, 0. And then this y equal to x plus 6 is just straight line, which is we have here intersect of y 6 and then intersect of x at negative 6. Means that we have this kind of straight line graph. So here you can see we have intersection point. This intersection point will give us, for this one is for example A, which is lower limit, and for this one it is B, which is upper limit. What we need to do first here, we need to find what are the values of A and B. How to compute the value? You can see this value happen when this graph intersect each other. Means that we need to make these two graphs, these two equations equal. That is here x squared actually equal with x plus 6, so that we can compute the value of A and B. When we rearrange this one, we have x squared minus x minus 6 equal to 0. And then we can use factorization with, or you can use your calculator, in which we got here x minus 3 and also x plus 2 equal to 0. So our x equal to 3 and another one x equal to negative 2. And these two x is the values of A and B. Means that here, because this one is the lower limit, the lower value, so it is A equal to negative 2 and our B equal to 3. Once we got this one, we can see directly from the figure here. This y equal to x plus 6 is the upper function, and y equal to x squared is the lower function. So how can we compute our area? Area is given by the integration of the lower limit, negative 2 up to 3, the upper function, that is x plus 6, minus the lower function x squared dx. When we solve this one, we'll got the answer x to the power of 2 divided by 2, 6x minus x to the power of 3 divided by 3, negative 2, 3. That is, when we solve this one, we'll got here 20.8333 unit square. So this is the area bounded by this straight line, this curve y equal to x squared, also A equal to negative 2 and B 3. That is the area for this region. What I did here actually, I solved first to get the lower limit and the upper limit, and then we identify which one is lower and the upper function, and then we compute the area, and we got here the answer 20.8333 unit square. So class, this is how we can compute the area if we have two functions, and this is the last part of the area using integration. In the next video, we will see how can we find the volume using integration. So class, thank you for your attention. See you in the next video.